Hello, everyone. I'm Sharon Ferris, Director of Marketing, Web, and New Media with CERIC. On behalf of CERIC, I'd like to welcome you to today's webinar. We are delighted to have with us Dr. Janet Miller, Randy Connolly, and Dr. Faith Michael Uzuka with us today. They are here to discuss their new CERIC publication, Computing Disciplines, a quick guide for prospective students and career advisors. They'll provide their insights on how this free resource can be used to support career development and student success. Before our presenters start, I would just like to take a few moments to introduce you to CERIC for anyone who may be unfamiliar with us. CERIC is a charitable organization that focuses on education and research in career counseling and career development in Canada. We fund research that advances knowledge in the field, like the research that you'll be hearing about today. And bringing you learning opportunities like this webinar is also a key part of our mandate. CERIC has three main programs: the Connexus National Career Development Conference, which is held in Ottawa each January. We also have our contactpoint.ca website, which is a free online community for career development professionals, and the Canadian Journal of Career Development, which is also free to access. You can learn more about all of CERIC's work at ceric.ca. Before we begin, just some quick housekeeping notes. If during today's webinar you have any questions, please enter them in the chat box that you see on your screen. Our presenters will respond to them towards the end of the webinar and also take some questions throughout if time permits. At the end of the webinar, we will email you the slides as well as the recording of the webinar. We also encourage you to engage with this webinar on social media using these popular Twitter hashtags that you see on your screen. It is now my pleasure to introduce the presenters to you. Dr. Janet Miller is a counseling psychologist with expertise in post-secondary mental health issues and personal development. In addition to working at Mount Royal University in Calgary for nearly 20 years as a full professor, she is the editor of Kaleidoscope, a certified trainer with the Center for Suicide Prevention, and an accomplished keynote speaker. Randy Connolly has been teaching at Mount Royal University since 1997 and holds the rank of full professor of computing. He is the author of 3 textbooks, the most recent of which is Fundamentals of Web Development, which is used by thousands of students at over 100 universities worldwide. And he is also on the editorial boards of the 2 main journals for computing education. And last but not least, we have Dr. Faith Michael Uzuka, who has taught computer science and information systems at various universities since 1992. He is a full professor of computing and a research development officer at Mount Royal University and has served as an adjunct professor in a number of other universities. He is on the editorial board as well as the program committees of several computing journals and conferences. I will now turn you over to your panelists.
Thanks so much, Sharon. What a lovely introduction. I'm not sure that my Twitter feed is at all a popular media, but thank you for listing it nonetheless. We are very excited to be here. We're going to talk about our booklet, The Computing Disciplines, that's just been published on the CERIC website. And we're going to, I hope, talk about how to use this for advisors as a tool to help guide clients in their career process. You've already done a bit of an explanation of who we are. Let's just do a little bit more about understanding the perspectives that we're taking here. I'm a psychologist. I work at Mount Royal as a counselor. So much of my work is involved with helping clients figure out their career trajectories, what they want to do in their lives. And I don't know a lot about the computing fields. So when I had this chance to work on a project with Michael and Randy, what an incredible opportunity for me to learn about computing disciplines and how to guide clients in that process. And then we hope that this booklet expands that knowledge and gives people a tool to work with. That's a little bit about my perspective from the practitioner point of view. Randy, over to you.
Well, I mean, sort of got a good start at this. I mean, we've been interested in the different disciplines within computing. We're in a kind of a non-standard university, and so our program was a little unusual, and so I've always been interested in the differences between the different computing disciplines, and this seemed like a good way of propagating that knowledge.
And Michael.
Yeah, actually, it's been exciting working on this project. I previously worked on computer personnel issues, and jumping on board to work on the computing disciplines was an exciting thing, and it has opened a lot of insights which we're going to share with you today.
Lovely. So we are 3 members of actually an international team of practitioners and researchers. We have Mark Schroeder, who works here at Mount Royal University with us in the computing department. Barry Lunt is from Brigham Young University, Craig Miller from DePaul University, and we also had the pleasure of working with Annabella Habinka, who is over in the Mumbrera University of Science and Technology. So what a lovely opportunity to work with people from Africa, from the United States, and from Canada on this project. So we're going to do our best to represent them well. Here's our plan. Our plan is to go through, first of all, the computing careers today, kind of a bit of the landscape of what's out there in terms of trends, occupations, just to give an idea of what we already know exists. Then we're going to talk about the pathway, the career pathway to get there. And do students understand the educational pathway required to get to these different outcomes, these different jobs? And then we're going to talk about the guide that we did, which I have here, like a fancy version. This is a printed version and it's available free online, and we'll show you how to download it, how to order print copies if that's suitable for your venue, wherever you are. So let's get started. And we want to do that really, first of all, by going into a poll, an audience poll for you to understand, help us understand who's on the line. We have a couple of 100 people listening in today, and we're curious about what role do you have? That'll help us to understand how to skew our conversation today. Are you an advisor, a counselor, an educator? Would you describe yourself more of a facilitator, an administrator? We didn't have other, but you're welcome to type in others if you need to. So you should have a little icon prompt on your screen to please answer this question. How would you describe the role that you currently have? Advisor, counselor, educator, facilitator, administrator. And we have our CERIC technology gurus helping us in the behind the scenes, and they'll close the poll and show us our results. Okay, I can't see the results. Maybe it's because I'm technologically slow here.
So we have 35% advisor, 35% counselor, educator 7%, facilitator 15%, and administrator 7%.
Fantastic. Thank you. Michael, you get to do the results page. That gives us an idea of who's here and that we're really looking at applications then. How can we use this information and apply it to our clients? Okay, we've got one more question to ask you in the same kind of format, and that's to help us understand what are your clients' interest in computers? Like, why are they coming to you to talk about careers in computers? Is it more because of employment prospects, the opportunity to be hired in these fields? Is it because it's interesting to work in? Has it got to do with mobility prospects, the idea of moving internationally or locally? Is it because of income, the high pay? Or is it cultural coolness? It's what every cool kid is doing right now. What makes you, or what is the main driver of your clients coming in? And Michael, I'll get you to do results when you can see them again.
Okay, I will.
Again, why are your clients interested in computing or careers in this area?
So
employment prospects is
85% for employment prospects,
yeah.
9%
Awesome.
for interesting work, 2% for mobility, interestingly, 0% for high pay, and surprisingly, cultural coolness made it to 5%.
That's awesome. Okay, so we know that employment prospects is a huge driver. People want to be employed. They want meaningful work. I like that there's a little bit there about interesting work and coolness. I'm not surprised that it's not about pay. It seems like a lot of people that I work with in career counseling, it's not, the income's not the driver. Hopefully it's a secondary piece and we want to make a good living, of course, but generally not the driver. So employment prospects, let's talk a little bit about these different careers today. Okay, last question, and this one's going to be a different kind of format. This one we want you to type in answers. Our next question to you is about computing in general. When you think about jobs in computing, these employment prospects, what kinds of job titles come to mind? What are the first words that come to mind? If you have a client who's interested in careers in computing, what kinds of programs or jobs do you think of? What are those prospects? What kinds of things come to mind? So I see coding, programming, media, more about programming, artificial intelligence, software development, programming. Randy, you called it, it is programming, game design, a little bit about software development. Okay, so these are the things that come to mind for us too, and we know that this is true of our clients, that more and more clients, when they're thinking about these career prospects or employment prospects, programming is the main thing that comes to mind for most of us. And as an advisor, that means this is what I'm mostly thinking of when a student comes in or a client comes in to talk about career development, but we know there's so much more out there. Randy, tell us about it.
Indeed, programmer is like the first thing that tends to come into mind, but there's a lot of other different fields. And in fact, if we went and take a look at all the different types of job titles that are out there, there's a vast, wide range of different types of skills that are needed in the industry. This particular slide just gives you a bit of a sense of the kinds of prospects that are available to someone who is looking for a future in this field.
And it's true, there are so many things we don't even think about. And as advisors, it's like you don't quite know what's out there, what that looks like. It's almost like searching around in the dark to find out what kinds of careers or themes are happening right now in this field.
And indeed, there's always sort of different job reports that are out there. Of late, there's been a lot of kind of interest in the so-called fourth industrial revolution, something that appears to be a kind of a computer-led approach. And one of the things we did is took a look through some of the literature to give you a bit of a picture of some of the kinds of jobs that are kind of for the next decade or the next 20 years.
Okay, so let's go through some of those themes and talk about these future careers.
Yeah, automation and AI is a key area now that is defining living today. It's a fast growing field and defines most of our lives, from GPS devices, personal assistants, robots, driverless cars, to household automation and even computer automated manufacturing and warfare. And a number of these applications seek to mimic the human thinking, how the human thinks, our natural voice, and the way we do things. And in the next decade, it's going to be the career of choice. It's recorded that over 15% of growth will happen in the next 5 years. And the average salary for the AI specialist will be about $25,000 more than the average salary of other computing professions. And there will be jobs out there for those who are in AI. Obviously, the survey indicates that people are interested in job opportunities. AI may be one of the places to go to for fast-growing job opportunities.
Okay.
So
cloud.
Yeah, so while AI gets a lot of name recognition, cloud virtualization has been a really huge part of contemporary computing life in the last 5 years, where companies are really replacing their in-house computing technology to third-party providers. And these third-party providers often have complicated, difficult interfaces to make use of. And so people trained in working with these will be a real opportunity over the next 10 years at least. Another thing that's kind of got a bit of hotness is the Internet of Things. This kind of refers to this idea that more and more devices, often consumer-facing, but not necessarily consumer-facing, that have connections to the internet and have their own data and their own APIs. And this working in this sort of realm is also an area that will have growth possibilities over the next decade for sure.
Yeah, and cybersecurity is another key area. The future of computing isn't technology itself, but rather our trust in technology. And arguably the biggest issue facing computer professionals over the next decade is related to internet privacy, data security, and all that. And it has enormous implications for businesses because a number of businesses have really suffered huge financial losses, and a few of them have gone down simply because of cyber security threats. And it's increasingly becoming one of the most important aspects of computing, especially when one considers the rapidly changing modes and intensities of cyber threats. So organizations are constantly looking for professionals who are going to be monitoring their computer systems, ensuring that they are secure from outside attacks and so on. So it's a key area that students might be interested in going into, and the job opportunities for this will be vast because they're applicable to a whole lot of industries. There's no organization that is not interested in the security of its critical data. So it might be an area that your students could be interested in because it spans various sectors and industries and economies everywhere in the world. Everybody is talking about cybersecurity. And the other area that people are not so cognizant of is the area of nanotechnology, which is basically a set of techniques that permit manipulation of properties at a very small scale. And these mass applications are likely going to have impact, particularly in the industry, in medicine, and in the production of computer systems. So some of the students may want to go into computer engineering, and nanotechnology stroke nanoscience might be an area that they would want to consider. They may want to be involved in the development of some of these micro devices. One of the challenges around nanotechnology is that it's less known, than other areas of computing. But we're increasingly developing small devices. Computer memory is getting small, processor systems are getting small, and every other aspect of the computer system is getting small. And people may want to jump into this aspect of computing and be involved in this area of growth that is very fast.
Okay, a couple more themes.
Yeah, data science. I mean, no surprise here. Big data is in the news almost every week, and this is going to be part and parcel of work and computing related work for easily for the next 10 to 15 years for sure.
Okay. Tell us about the gig economy.
I think this was supposed to be yours, Janet.
Oh my gosh, I wish I knew more. This gig economy, this idea of, I guess for me, when I think about gig economy, I think about using small contracts, going kind of like from gig to gig, almost like a musician would have done back in the day. Small, contained experiences. Maybe I'm a consultant or working as an entrepreneur. So that's what I think about with gig economy. Does that fit with what we're talking about with trends in computing?
Absolutely.
Obviously.
Okay.
All right.
So we know that in this area of computing that employment growth is on the rise. You guys both talked about several stats, and we know that employment in these areas is growing rapidly. And in many cases, there are going to be fields or trends that don't even exist yet that we're training people for. So we were curious about how you get there. Like, how do we even talk to people about education and training to move towards these different trends and to speak to trends that we don't even know exist yet? So Randy, tell us a little bit about how we set up our research project and what our hope was around the ACM.
Well, quite some time ago, 8 or 9 years ago, we sort of started this research project about trying to better understand how much do students and faculty understand about the different computing disciplines. There's a real tendency to think of computing education as being computer science, and that's it. But there's more, there's other computing disciplines, and we were curious, well, how much do students understand?
So there's these 5 ones out of ACM. What is ACM?
That's right.
And an
So,
overview.
so computer science, the one right in the middle of the screen, is the one that sort of has the most name recognition. But the ACM, and the ACM is the Association for Computing Machinery, which is kind of the North American body which determines curriculum and makes recommendations and so on. They've got some other disciplines. So information systems has been around sort of the second oldest. It's been around since the 1980s. It's a bit more business focused and organizationally oriented, as we'll see a little bit later. Software engineering came on the scenes in the late 80s, early 90s, and it's somewhat similar to computer science, but it tries to take engineering practices and principles into the creation of software. Computer engineering is a bit more traditional engineering oriented in that it's about creating the hardware and the embedded software systems within hardware. And then the newest one on the block is information technology, which has only really been around for about 10 to 12 years. And it attempts to be a discipline that's maybe more suited for people who, for prospective students that want a degree that's got a practical and applied side. And so Michael and I are in a department that has both computer science and information systems / information technology. So we were familiar with this problem of how do we get students to understand these different disciplines better? And that was the focus of our research.
So that was the main question, and that was something that really interested me too, because I can throw out these different names, but without having an understanding, it was hard. What did you guys find out, or what did our research show in this area?
Well, we were a bit surprised. Here's the answer. Here it comes. Wait for it. Hardly. We just couldn't fit yes or no in this. And go ahead, Michael. You explain. Okay. You describe the study.
Okay, so we had a survey. We surveyed over 600 students and 13 faculty, both in North America and in Africa. That's in US, Canada, and in Africa. We designed our survey in such a way that students who have the ability, students and faculty, the respondents who have the ability to associate a given task with a given computer discipline. And that will show us their understanding of the computer disciplines. And our survey also recognized the fact that certain tasks overlap 2 or more disciplines. So we had our survey on a 5-point scale from 1 to for no fit to 5 for best fit. And then we also provided an opportunity for people to indicate that they weren't sure of the fittedness of a given task to a given discipline, and that was 0. It was a pretty complicated survey, but it captured a lot of what we intended to capture from the faculty and students.
Well, and what's so great about that is that sometimes we think about, what do I want to be doing? What are the tasks? Maybe I don't know the job title or the education pathway, but I know what I want to be doing. And we found that students who get channeled into one program, let's say computer science, who really want to be doing other tasks that belong with other disciplines, it's very hard to switch between academic programs. And we all know university and college is expensive. So we were trying to also help students pick things that fit with what they wanted to do. Let's go through some of the different results, and then we'll get on to our teaching booklet.
So if you look at the radar chart on the screen, you see that we charted the students' response with those of faculty and found out that there were some similarities between faculty and students in certain tasks. For example, the first task there designs hardware to implement communication systems. The students and the faculty believed that this particular task belonged to the computer engineering profession. And the second one, they believed it belonged to both the software engineering and the computer science professions. But the students were less sure of the specific task belonging to a specific discipline. They were probably more cautious. So the faculty were more pointed in deciding that a given task belonged to a given discipline. But there were similarities between faculty and staff in some areas, especially those that we can see on the screen. Whereas in some other areas, next slide, in some other areas, there were no similarities between faculty response and student response regarding the fittedness of each of these tasks to the various disciplines. And the two that you can see on the screen are some of the tasks that are a bit fluid in terms of where they belong to. One of them, developing and maintaining websites. Most of the computing disciplines will be involved in the development and maintaining of websites, except probably the computer engineering discipline. And then managing team of software developers. Most people will say, oh, computer scientists manage team of software developers, and some of them will say it's IS people that manage them, and some others will say it's software engineering people that manage them. So most of these disciplines that have some bit of overlaps in terms of their tasks, okay, show up as dissimilar answers. And that's what we're seeing here. And that's the confusion that people have out there. People come into your offices and they're interested in being a web developer, and they're not sure if they should go into computer science, or they should go into IT, or they should go into information systems. And what our current handbook does is to attempt as much as possible to create those distinctions and clarifications for students and counselors.
Okay. Okay, we got one more slide here on results, looking at the different student groups.
Yes. So the student groups, what we did was that we clustered the responses from students and those from faculty, okay, and had an average cluster weight to find out how correctly these students understood the computing disciplines. We used the faculty response as the accuracy level. It was a benchmark. It wasn't a perfect benchmark, but it was a good benchmark because the faculty determined what they want to teach the students, what should be the curriculum for these programs. And then we realized that the computer engineering students were able to clearly identify these disciplines more than every other set of students. Information system students were equally good. But very interesting is the fact that the non-computing students and other computing students were able to clearly distinguish these tasks and associate them with the disciplines better than software engineering and computer science students. And if you look at software engineering and computer science, these are fairly traditional subjects that have kind of boundaries and silos, a little bit impermeable, that they believe that a number of tasks belong to their disciplines, okay? And so they are not able to distinguish and differentiate between their own disciplines and other emerging disciplines such as IS and IT.
Okay. I see that Randy's having a bit of computer trouble with his video feed, so we're just going to kind of go on and trust that he'll join us again in a moment. So we know that our clients need help in finding their direction, that it's not like it's a clear path and not all paths lead to all occupations. So that's really where this guide came in, that we wanted to develop some kind of resource that could be in the hands of people like me to take information like Michael and Randy are talking about and make it understandable for the non-tech world, the advisors and counselors who are not familiar with all these trends and possibilities out there. And that's really where this CERIC resource came from. We are so grateful that we had support from CERIC. We received a grant to do this booklet, and it's available for a free download. And we are going to go through the teaching elements of it and how to use it to hopefully benefit your students or your clientele. We know that some of you are working with adults and older adults looking at a different or maybe a second or third career. So this booklet, it's 30 some odd pages. It's very visual. Randy did all the creative design in it. He's also just finished the French translation version. So that is coming out momentarily. The edits were just done actually an hour before we went live today online, which is fantastic. So you're going to see this coming along in a French version as well. We're also pretty excited that we have an American version that's in development. It's been picked up by some people down in the southern part of the United States, and we hope that we're going to also translate it now into more of an American context with universities and colleges that are more contextual, because as you'll see, we've done a lot of research about what fits in the Canadian environment here. We know we've got people listening in from other parts of the world, so some of the resources you're going to find are very Canadian specific, but hopefully there's enough information in there to orient you in your own place of work and study. Okay, hopefully Randy's back on just in time to talk about how he has laid out the book, because we've really done it in a map type style.
I wasn't interested in listening to Janet or Michael, so
Whatever. That's right. You're
all
back
right,
on.
So, what I missed, but yeah. So part of the problem about all of this is that everyone seems to know that there's lots of jobs in computing, but it's always been difficult to try to how to get students to take it, and how to find a program that's going to suit their interests. There's a great deal of attrition, we call it, in computing, where tend to lose half the students in the first year. And that often happens in computer science because it's not really the appropriate program for those particular students, but they might be interested in a different computing program. So young people, as we all know, are less likely to do a bunch of reading. Actually, we all are less likely to read now. And so the idea when I was putting this thing together was to try to come up with some kind of visual metaphor that would explain, in a sense, what the difference between these disciplines in a kind of quick and easy to grasp method. And the approach that I used was a bit of a city metaphor. And so each discipline, in a sense, was its own city district. And so we'll see in the next couple of slides what that ended up looking like. And so for each of the 5 disciplines, I tried to encapsulate the information into 4 pages, an overview page and then a details page. But the heart of the disciplinary story was a kind of an outside and an inside look. So the outside look was kind of like, well, what does the discipline say? What's the traditional definition of what that field is all about? And then the inside view was the practitioners themselves, the people who are, for instance, working in computer engineering. What did they say about their job? And that was kind of the approach that we did, and we'll show you some examples of what those pages look like. So with computer engineering, we tried to capture a little bit of a visual flair of what they did, what they do, and some key words, some key phrases that maybe, again, capture in general what a computer engineer does.
Now, we did get those words or traits of people by looking at different career websites, a few different tools that we maybe use in our practice to try and look at attitudes, orientations, what a person who's attracted to this kind of field might be interested in. Okay, outside view.
Yeah, so city. So I thought, okay, let's try to create a circuit board. So like a circuit board city. This is the computer engineering city. So that's the basic. And hopefully we should see, here they come. And this is the big picture, what others, such as the ACM, says about the particular discipline. And these things might appeal maybe more to an advisor, perhaps, but it's the next page where we have the inside view, where we try to show, okay, people doing some, maybe typical computer engineering tasks. We have a sort of a spokesperson who kind of tries to give a big picture about what they do, and then different people within the inside view sort of saying, oh, this is what we kinds of things that we do, to get a bit of a sense of, oh, this is what a computer engineer does. And then at the bottom of each of these inside views are sort of spokespeople for the other disciplines saying, hey, we do some of the same, but in a different way, because, as Michael alluded to with some of those radar charts, there's a lot of overlap in particular tasks. And that's one of the things that made constructing this particular document tricky, is because of that multidisciplinary nature of many computing tasks. Finally,
well, here's some examples. First of all, the other inside-outside views.
I forgot about that. So here's computer science. So I had a colleague I was off on sabbatical in Austria last summer, and she said, computer science looks fun. I think I want to be on the computer science floor. So I tried to make it a bit more theoretical or a bit more future oriented, which is one of the features of computer science, is that it's more general purpose, and it is often oriented towards more abstract tasks.
Like innovation, new ways of using computers. And again, I like this outside, what I might see from the outside as a non-computer person, but then the inside view is a bit of like day in the life. What will I actually be doing? What are those tasks? I like that a lot, Randy. It makes it so much easier to talk to clients about these fields. Give us an example of another one.
All right, well, the next one, information systems is more business oriented, more organizationally oriented. So it made sense for the city view to be both a combination of a kind of a commercial district, a business district, and an industrial district. And then the people inside are working on quite a wide range of different tasks, from sort of higher level business views where they're deciding maybe the approach of a company as a whole, all the way down to the bottom where they might actually be doing software development and so on. Another thing that we wanted to try to capture with all of these diagrams is that computing is a really social activity. The cliche, of course, is the solitary person working in a cubicle in a basement, but the reality is that almost all computing work happens with teams, with groups of people. It's actually a type of activity that's well suited to extroverts.
Was the beehive intentional in this one?
Yeah, the idea was to try to capture the fact that there's a lot of different floors, if you will, a lot of different types of things that one can do within this particular discipline.
I like that interactivity. Here's another one.
Information technology, this is the newer one. This is the one that's a bit more applied. And so in the inside view, we tried to capture this idea that you might be supporting servers, you might be setting up hardware, you might be monitoring and controlling the way these things work, you might be working in a software development path, you might be working kind of in a more organizational aspect. So again, we wanted to try to capture the fact that there's different floors, there's different types of activities that can all fall under this one particular discipline.
Now, Randy, one of the things I learned when we were doing this is that IT is not always called IT, that it might come under different names or different labels.
Indeed, IT is often used as a generic term to refer to just information technology in general, but it's also a specific discipline, and sometimes a program that the ACM might say, oh, that's an IT program, might be called something very, very different. It might be called an IS program or computer technology program. It's hard to say.
Okay.
And then finally, there's software engineering. For the outside view, it made sense to try to connect it to sort of larger scale industrial exercises. But the inside view, I wanted to try to capture the fact that you're often involved in the planning and the testing and the careful evaluation of software development. So software engineering has a lot of similarities to computer science, but some software engineering programs are actually housed within traditional engineering faculties. But at other schools, they might be a major concentration within computer science.
Okay, so there's one other way you describe these things, and these blob charts are my favorite, I think, to use when I'm talking with clients. I know they were inspired by the ACM. Can you kind of walk us through what these pictures look like?
So, so for each of these, it can seem a little overwhelming, but if we look on the left-hand side, we see at the top something that's really human-focused, business-oriented. But as you go down towards the bottom, towards computer architecture, you're more and more focused on the machines themselves. So software methods is algorithms, system infrastructure is more about how particular hardware connects with larger systems. Computer architecture is very much the lowest level. So computer engineers, as you can see, are very much focused on computer architecture, but they're not really at all focused on business or human-focused aspects, and that's illustrated by this design. On the x-axis, we see a move from very theoretical, mathematically oriented kind of approaches over to the other side, where it's much more applied, much more hands-on. Computer engineering has both, but as Michael will show you with some of the next disciplines, some of these other disciplines are more focused on the applied or more focused on the theoretical and so on.
So I love this as an advisor because I can do almost like a self-assessment of those 5 qualities on the left, and I can talk with my clients about applied versus theoretical and then look at these charts, or I can do it the other way around. I can look at these charts and then use them as a discussion forum. So I like that. Can you just, before we go to Michael for the other ones, can you say a little bit about ACM's involvement with these? They don't look as pretty as what you've designed, but it was inspired by their curriculum.
That's right. Like ACM has, in 2005, they created a document called Computing Curricula, which is kind of an overview of the 5 disciplines. They're revising that particular document, so maybe within another year or 2, they will have a revised one. But this, as Janet mentioned, it ended up being a kind of a nice way to visualize the differences in the disciplines.
Okay, Michael, a couple minutes about the other ones. Let's do computer science next.
Yeah, so as Janet said, these diagrams could be good advising tools. In fact, if I have all the 5 diagrams on one page, I can comfortably direct my students on which career paths they want to take on. If you look at computer science is not about the architecture, the deep-rooted hardware things. It's not also about organizational things. Computer science falls in between, but it's more towards the theoretical side of things rather than the more applied side of things. And any students who is interested, it all boils down to the student's interest. Am I interested in organizational things? Am I interested in coding, software development? Am I interested in building computer systems? So computer science falls between mostly around the software development side of things, but using theoretical principles. And then information systems, as you can see, the chart, the map, it's
totally
that's
different.
Nothing about computer architecture. It's totally different. It's more about organizational issues and a little bit about applied aspects of software development. Next. Can we go to the next slide? Information technology is almost like information systems, but as you can see, information technology is crazily about the applied side of things and focusing on both organizational issues, software aspects of the organization, and system structure, but it's mostly towards the applied side of things. Okay, next. And then we have the software engineering. I like that spherical map because software engineering is all about software, both from the theoretical side of things to the applied side of things. They're developing software, they're looking at new theories and new techniques for developing large scale and functional software for organizations. And so let's see the rest of that slide, the full slide. So in our work, we try to look at what the student will be doing on the job. And that's one of the things that the pamphlet will be showing you. What are the kinds of tasks that they will be performing on the job? And what are the core courses? Someone might be interested in a lot of computer science, algorithm kind of job, and so on. But that person is not mathematically inclined. So what are the kinds of courses that that person will be taking in the university? And as a counselor, this page will be very, very useful because you could show the student clearly, If you say, I want to be a computer science person, now are you able to do all the mathematical courses, the data structure, algorithm, and all that for computer science? Or you say, I want to be a computer engineer. And computer engineering requires signal processing, some design things, circuits, and electronics. Are you able to do those kinds of courses? And if you're able to take those kinds of courses, then we begin to look at sample programs where you fit into. If you come to my university, for instance, we have the computer science option and the computer information systems option. So your choice might inform the advisor on the direction that you should go. In fact, when we had an open house, this page was a very good tool for explaining to parents the difference between computer science, information systems, information technology, and the blend of information systems and information technology in certain programs to give us what we call the computer information system. So this is a cool page for, and
Randy,
obviously focused on the Canadian universities. As Janet earlier on pointed out, we are developing versions for North America, for the US, and for other countries where we have people being interested in translating this pamphlet to their peculiar contexts.
Randy, we also chose to add in colleges. Can you say a moment why we didn't just focus on university training?
Well, because we got asked to add them, but it is true that there are, not everyone's interested in a four-year program. I mean, you're losing certain things with a 2-year program for sure, but in certain kinds of fields, a 2-year program, might give you, close to the same experience as a 4-year program.
Or a more specialized or specific training. That makes sense.
The thing that makes all of this really tricky is that you've got these different disciplines. These disciplines have a kind of idea, an ideal for what they're trying to achieve. We showed you the diagrams and some of the courses and so on. But the problem is that there's a bit of a mismatch potentially in that there's these different jobs, and that these jobs, certain kinds of jobs, may be happy with a computer scientist or information systems or a software engineer. And so the way that we might think of this is that the disciplines are pathways to jobs, and that some of these jobs have multiple pathways leading to them, which makes it a great field, but can make it a bit tricky from an advising standpoint for sure. So we tried to capture this fact a little bit in our next page here, where we listed a series of standard, typical job titles within the IT field or in the computing field. And so some of them, for instance, computational scientist or hardware engineer, you can see that probably if you want to have that kind of job, there's a particular discipline that you probably would want to take as an educational path. But other positions, so for instance, come on, there we go. To be a security analyst or a software developer, there's any of these disciplines might get you there. So for a security analyst, maybe not software engineering or computer engineering, but CS, IS, or IT would be a great background or a great pathway into that kind of field. And so I think this is an important kind of page to show potential clients, to show them that there's a lot of different job titles, but there's also a lot of different pathways into those job titles.
Okay, so hopefully that makes sense, this idea that there's different pathways to get in. And for this reason, we really want you or encourage you to ask your clients about the kinds of computing work that they're interested in. So not just the tasks they want to do, not just the trends that they've already heard about or the program they've heard about, but what kind of computing work are they actually interested in? This might help us to guide them along a pathway of education. And on top of that, there's another way to talk about it, and that's looking at the tasks that you're doing, right, Randy? Like, or the kind of
That's right.
day-to-day focus that you have.
So in our booklet, we right towards the end, go ahead and click through this, Janet. The idea is that there's different types of categories of work. We often focus on development, but there's data related work, there's design related work, there's infrastructure related work, there is business related work, and finally there's management related work. And that within each of these floors, if you will, there's also quite a wide range of different types of tasks. So this is separate from the different disciplines. Right at the end, you might not have caught that. Oh,
sorry, I'm gonna go back. Sorry. Yeah.
There we go. You'll notice on the development floor, there's 4 people there with sort of white halos around them. And the idea there is that the development is often a stepping stone for other types of work. So one might start in development and then move on to design or to data. But there's movement between these floors, and that's a key thing. And that's one of the things that makes it a great field, is that you're not stuck doing the same thing for 30 years, that there's a lot of mobility within the broad computing field.
Randy, I just want to lace in a few of the different questions we're getting. We've got about 10 minutes left, or 5 minutes maybe of us. One of the questions was, where does networking and telecommunications fit in? This might be a good way to answer this.
Infrastructure.
Okay, thank you.
And in fact, we'll see that just shortly. Let's just work our way through these slides, through these floors quickly. So within development, so these are some of the more common job titles. Let's keep going. Within data, you can see that there's some exciting things like security and data mining in here. If we look on the next floor in the infrastructure, we'll see, look at this, DevOps, networking, computer operations. That's where a lot of that area is. On the design side, we see some of them, they get to sit in the fancy beanbag chairs, UX design, information architect, usability, multimedia, different kind of work there for sure. Over in the management side, business side, you can see some common things, and let's just keep working our way through these. And then finally, management. Again, these are typically things you might do later in your career, but lots of excitement there.
One of the questions, guys, was about computer people who are also creative minded. Where would you direct them if I am working with someone who's very creative, innovative?
In any of those words, like, I think it's a real kind of misnomer to think that somehow creative work is only artistic related work. I mean, programming is probably the most creative work that you can possibly do. It really, really is. But if it's traditional art focused, yeah, the design side of things, the UX side is often there.
Thank you. If you have other questions, please type them in and we'll do our best to get to them before we're done here. So we also want to remember that while content-specific information and training is, of course, super important in these careers, we also know that employers are looking more at skills that are more on that soft side. They're looking beyond things that are specific to computing. We can't forget that in our advising. So we just want to do a quick little reminder about these soft skills that we know employers are looking for, and we want to encourage our clients to highlight in their curriculum vitae or their resume or their cover letters, and of course in their interviews. So things like communication, super important, verbal and nonverbal communication, written, verbal, in person and online, social media, etc. We know that teamwork is going to continue to be important even in an online world, and we want to encourage our clients to highlight this in their work and again in their resumes. Leadership. Ongoing, we find this with young people, that leadership opportunities where they can not just lead in the traditional sense, but lead from behind and create activities that bring other people along and motivate them is very important. Self-motivation continues to be one of the drivers in all of these different fields. A self-starter, someone who doesn't require ongoing hand-holding per se, but that can take innovation and direction. We know this to be true. Michael, in a context of education, how do you encourage people to develop these skills?
Obviously, to develop these skills, you need to take some additional courses. It's not just the computing courses. Some people do some minors in business and even the arts. And you can also take additional non-credit courses in some of these soft areas, especially from the faculties of business and arts.
So this brochure, this pamphlet, this book, I'm not sure, it's very detailed. So it's got information that will allow verbal learners, people who would rather have those blob charts to understand things. We hope that this is going to be useful for you to give to your clients or to photocopy pieces of it and share. Again, you can order print copies, but it's a free downloadable resource available online at CERIC Publications. Michael, one of the questions that we had was about the blob charts, where it's mostly in the middle, sort of in between practical and theoretical, or applied and theoretical. Maybe the software engineering is one example of that here. Can you just describe when it's kind of more, the blob charts more in the middle, that balance? Just a quick description of how it can be a little bit of both.
Yeah, people who are creative and people who are practically oriented can decide to go in for software engineering. And a number of people are not just interested in software development, but they're also interested in the intricacies of software development. How do you design your system? How do you make it, a better fit for the organization? And when you get such students, software engineering and all those kinds of disciplines that are both on the theoretical and practical side of things will be best for those kinds of students.
Thank you. Randy, there's a couple of questions for educators. If you're trying to help students get more experience, have you found that there are more project-based or contracted related opportunities or full-time, part-time work? Like, what are your students leaving to do post-graduation?
Well, it is a bit of both, for sure. I'd say often when there are students that are starting out, they do a lot more contract related work. I mean, it is a field that really is ideally suited to that kind of work. It's actually great for people. It's a great career for people when they're moving into, having a family. Like it has that kind of flexibility that you can do part-time work, that you can work at home. It really is ideal that way. But and there's you can work anywhere in the world, which is nice. You can have clients in Budapest and then work in Manitoba. Like it's
That's so true. Oh my gosh, there's a few other questions coming in about soft skills, encouraging people to think about this as a transferable skill occupation, that if you're working in computing and looking at changing your career to a different field, there are so many transferable skills embedded in these careers. And this booklet hopefully gives you a bit of language for that.
Yeah, and it is one of the things that makes this actually a really nice field for people, is that you can move into a lot of different kind of work. It's really, really common for someone to maybe start, I don't know, doing network support, maybe then move into programming, and then switch over into management, and then go and do sales. Like, who knows? Like, it's it really is ideal in that kind of way.
That's awesome. We did want to give a shout out to Riz Ibrahim before we were done. Ibrahim, I just butchered your last name, Riz. I am so sorry. I adore you and appreciate you. I have found that Riz has been super helpful for guidance for this project from a distribution point of view in particular. This webinar would not be happening if it wasn't for CERIC. The booklet would not be as well distributed if it was not for this group of really lovely people, including Yi, who is behind the scenes right now on this webinar, and Sharon. We are very, very grateful. We have a quick end of webinar questionnaire we could ask now if you wanted to, guys. Just do we feel like it's okay to ask people if this was helpful? Do you feel confident? Was this helpful? You can just type in answers, or you're welcome to do an actual poll, Yi, if you want to. And then we'll end with our last thank yous. Michael, any last minute comments, 30-second last words from you?
Yeah, just to say that we're excited about this project, and we're inviting collaborators from anywhere in the world. We want to reach as many parts of the world as possible. Thank you.
Yes.
Yeah, we've also had some interest in some groups that are looking at maybe adopting this approach for younger people, for people in their sort of late elementary school, early junior high school age, which would be kind of exciting.
That would be really exciting.
I did not see the results of that poll.
I think we'll look at them later. Hopefully they're positive. I've not seen them either. Randy, for you, I just want to say thank you for designing a booklet that is so visually appealing. This has been so helpful as an advisor, as a career counselor, to make it just so much easier to talk to my clients about a field that I don't well understand or didn't. And now I've got a lot of resources to help me. And I'm seeing comments that are the same here. So thank you guys for it's a fantastic teamwork. I'm so happy to have been a part of it. Please email us if we can be helpful. And I'll turn it over to Sharon for the final minute.
All right. Thank you so much, Janet, Randy, and Michael. And just for your own reference, 90% of the people on that poll said that this webinar and the guide have helped them learn more about how to advise around computing careers. And I have to say, from a personal perspective, I'm pretty familiar with the guide, but I've learned a ton today listening to you three and hearing it straight from the creators. So creatively put together, so many different layers to the guide, and so many different ways that advisors can use it to work with those students. So fantastic. And as you mentioned, I just wanted to remind everyone that you can go and download your own free copy of the guide from the URL that you see on your screen, ceric.ca/computing. And as mentioned at the beginning of the webinar, we will email you a link to the recording of this webinar and the slides later this afternoon. As well, at the end of the webinar, you're going to be prompted with a survey. So please do take a moment to fill that out because we greatly value your feedback. You'll also notice on your screen right now that we have some upcoming webinars that may be of interest to you. And so with that, let me close by thanking you, the participants, for joining us on this webinar, and we hope to see you again very soon at another learning opportunity. Enjoy the rest of your day.
Thank you.
Thank you.
Thanks.